I'm going to steal some of Mike's thunder. Mike is a superb teacher of CW. And some of the people in here have taken his classes and have learned a lot more than they thought they ever could. You know, old dogs and new tricks and all that kind of stuff. Mike's able to work around that and get you into a band that some people thought would be abandoned, but is very, very popular. It works very well when conditions are bad. All of you know about CW. Some of us even had to pass a CW proficiency test to get our licenses, but then we're old. So anyway, without further ado, N6 MQL.
Thank you, Bob, and thank you for having me here tonight. Appreciate it. Tonight we're going to talk about the RigExpert antenna analyzers. Some of you may own an older version of this. I didn't bring one because the reason I'm here tonight is to... No, that's okay. You know what? I'll see if it'll light up for me. Even better. See? So the reason that I'm here is because RigExpert has introduced a few new models to their lineup, and they've just discontinued the older models that many of you have. So if you were here 2 months ago, you saw Phil's presentation on the phased vertical antennas. And in that presentation, he used his AA-230 analyzer, which is a 100 kilohertz to 30 megahertz antenna analyzer. That analyzer served its purpose very well for many years, about 10 years. And it is now been obsoleted and replaced with the new version called the AA-35 Zoom. The AA-35 Zoom is also accompanied by an AA-55 Zoom, and this particular model here, which is an AA-230 Zoom. So what you see here is, the first thing you might notice is it's colorful. None of the other antenna analyzers, unless you got the 600 megahertz and up, more robust and almost professional models, were color screens. Now the lower models are also being introduced with color screens and some new features that are not available on the more expensive 600 model and above. So this is just one of the models that we have. Again, is the AA-230. I'm an importer, vendor, and distributor for RigExpert products in the United States. And my company is called PNC Engineering. RigExpert USA is the importer. PNC Engineering is the online sales and distribution channel. I'm also the US Warranty Center. There is no other real warranty center, so when you purchase from us, we make sure that you get taken care of with a really nice 2-year warranty. So all of the products are looked at very well before they go out the door by myself. I don't approve anything leaving the door until I've actually checked it. And then those warranties come, if you purchase from RigExpertUSA.com or PNC Engineering, my company, you receive free technical, operational, technical and operational support, and that's by way of chat, online chat, email, or telephone. So you get a lot of service and support through my company and through RigExpert USA. So let's have a look. The new model out. The new model out is the AA-55. Kind of comes out in between the 230 and the AA-35 Zoom that I talked about. All of the analyzers are made in the Ukraine, and they're made by RigExpert. RigExpert is actually called RigExpert Ukraine. RigExpert USA is in the United States. It sits very close to my location in Carmichael. So when you purchase from my company or RigExpert USA, you're getting your analyzer out of California. It's not being shipped from the Ukraine. RigExpert also makes a lot of other equipment too. Many of you may know the Rig Blaster, I believe that was, or the TI-8, that was a unit made by RigExpert Ukraine. These are interfaces that connect your radio to the computer. It got rid of ground loops and hums, and it also allowed you to be able to key your rig with the computer and send data transmissions. They've also introduced new T-hunting equipment, something that's similar to this loop that Carol has sitting here. It's a direction finder. This is not the RigExpert. This looks like a homebrew,
Yeah.
and I'm sure Carol will tell us about that. But it's fine either way.
Which is best?
Oh, I like it dark, so then nobody can see me. I prefer that. There you go. And you can see it. There's more information up there than I'll give you. But they do make a new T-hunting piece of equipment. You can check that out at RigExpert.com. That's the Ukrainian site, and there's a lot of information there. All of the analyzer models can be found at RigExpertUSA.com. So currently there's 11 models, that's true, but 3 of those models are being discontinued currently, as I discussed. The AA-230, the AA-254, and the AA-170. And those were replaced with the AA-35 zoom, 55 zoom, and the 230 zoom that I just held up. So soon to be 3 less. Frequencies on the new analyzers start at 60 kilohertz and they go up to 2.6 gigahertz, but not all of the analyzers go up that high. The number of the analyzers model determines the frequency that its highest operation. So for example, the AA-55 goes to 55 megahertz. The AA-230 goes to 230 megahertz. All of the analyzers except for one particular model, which is only available through RigExpert USA, which is an ISM-based Zigbee Wi-Fi analyzer. All of the other models go from HF through their frequency of model number. So we have an AA-1400, which covers up to 1.4 gigahertz. That's really good for people who have 1.2 gigahertz radios, and that analyzer also covers HF. So it has multiple detectors and filters in it so that it's capable of running accurately all through all of the bands. So analyzers, as you see here, are broken down into the HF 60 through 55, the VHF to 230. UHF, there are 3 models. There's a 600 going to 600 megahertz, 1000 to the 1 gigahertz area, and the 1400 that I just mentioned, which is the 1.4 gigahertz area. The model that you see there is the 1400. As you can see, it's much different looking than the model that I held up here, which is the AA-230. This is more of a consumer-based model, whereas the 1400, as you can see, has a little bit more of an industrial design on it. It has a metal plate on the top where the end connector is mounted, so it's a little more robust, and it's also larger in the hand. It's about this tall, so to about the top of this connector here. I do have an AA-600 in the box new. If you're interested to see it, I can show you that. That's a very popular model because you might have noticed that I didn't mention any other UHF analyzers that cover the 440 meter band until we got up to that 600 model. So currently there is no UHF zoom model analyzer. It's something that's being discussed. It's in R&D right now, but no prototype has been made. Probably next year, first quarter, you'll see something around the 700 or 800 megahertz range come out. So it'll probably be called the AA-700 or AA-733 zoom. Again, I don't know when it'll come out, and as for the price, I would imagine it will be probably around the AA-1000 price range, which we can talk about in a little bit. So, what you're seeing there is the then and the now. So the old model, you can see they share a similar case, whereas the features have grown considerably. Before we had the AA-54, which is being discontinued, you see that the screen is a monochrome screen, it's not color. And the way that the screen functions is you had one solid line and one dashed line. And when you're making a graph that had 2 representations. In this case, that would be a resistance and reactance measurement. And in the screen, You can't really see which one is the dashed line because of the resolution. But one of the problems that it had is when you would land on one of these lines here, where it's part of the graph, if it was the dashed line or even the solid line, you'd actually get lost within that line. So if you had a perfect one-to-one SWR, it was at that baseline and you wouldn't even know you had any SWR unless it just happened to bubble up from the bottom of the line. So it became very difficult to see. The old analyzers were 8 and 10-bit analyzers, so they used a fairly simple CPU in them. And they made actually an 80-point plot, not a 100-point. And they only operated in a 50 ohm and 75 ohm environment. Whereas the new analyzer that you see on the right, that's the AA-55. If you purchase it from RigExpert USA or PNC Engineering, we're actually giving away a Smith chart with the analyzer as opposed to the standard, which is a polar chart. And the display, as you can see, is color. There are different models. The 55 is a 12-bit. The 230 is actually a 16-bit analyzer. All of the upper models, 600, 1000, and 1400, are also 16-bit analyzers. The native impedance on the AA-55 is 25, 50, 75, and 100 ohm. But on the 230, you actually can also receive 150, 200, 300, 450, and 600 ohms, which means that you can connect it to a ladder line, and you can be native impedance with a ladder line and check that. So you really don't need a balun to check your impedance. Before, you'd want an unun or some type of coupling balun to get it near that 50 ohm unbalanced connection for the top of the analyzer. Now you could use a banana jack. Another feature that it has is the ability to make a graph in loop, meaning you can push the button and instead of just making one sweep, it'll continuously sweep your graph over and over. So if there's changes in the antenna as you're adjusting, or if the wind is blowing and something's changing, you'll see it each time it makes a new pass. So that's the loop graphing mode. It also has some Coax tools. We'll talk about that in a few minutes. These are new features that make, well, for example, that make what Phil was doing a lot easier. In one case, he was making stub matches where he needed to make a coax stub match between the two-phase verticals, and in order to do that, you need to have either a quarter wave or a half wave piece of coax that's resonant for the frequency of the antenna. This is part of what makes it directional. So with these coax tools, those things are built in and there's no calculating as Phil had to do. And then, as I said, there's the Smith chart. And finally, most importantly, for a lot of guys, is the speed. Although the monochrome units were pretty fast, the new 55 and 35 units, they're really fast. I mean, you push the button and it sweeps across in, I'd say, less than 3 seconds, if that. So, really helpful. So what do you do with an antenna analyzer? A lot of you guys are sitting there and you just got your ham radio, but you don't even operate that yet. So let's add one more thing to your mess of equipment that you have no idea how to use. That's pretty common. So, and you should keep adding. Everybody should always add. If you have an antenna, you need an antenna analyzer, honestly. If you have an HF antenna or you like to build antennas, it's absolutely imperative. If you don't, you can't just trust the SWR meter on your radio. They just don't function the way an analyzer does. An analyzer helps you make rapid checkouts of the antenna, graphing or in fixed modes. It helps you tune your antenna to resonance. A lot of people think that SWR is everything. People think that if you've got a one-to-one SWR, then you must have a perfect antenna. But that's not necessarily true. If you don't have a resonant antenna, then you can still have a low SWR on some antenna analyzers, and you think you have a good antenna, but you have no resonance. Without resonance, then you're not putting out any energy from your antenna. So you may as well have a perfectly tuned wet noodle. In other words, you don't have any energy leaving the antenna, but for some reason or another, the analyzer is showing you good impedance, or rather, yes, good impedance, which would equate to good SWR. Impedance is made up of reactance and resistance. This is basically an imaginary resistance and a real resistance. As you know, resistance resists energy, and if you have too much resistance, then you have no energy leaving your antenna. So the imaginary resistance, we want to keep that as close to zero. That's your reactance. When you have perfect reactance, you have zero imaginary resistance. Because our radios like a 50 ohm impedance, you want the real resistance to remain at 50 ohms. That keeps your transistors happy, and they send all of their energy out the transistor to the antenna when it has a 50 ohm impedance. These antenna analyzers are what they call vector analyzers. Vector analyzers make a vector calculation. They use the resistance, the true resistance, and the imaginary resistance to come up with a vector calculation. That vector calculation determines the impedance, and in turn, the impedance is the SWR. When you get into other brand analyzers, what you end up with is analyzers that take a measurement of voltage and they interpolate that voltage measurement into a resistance for imaginary resistance. And as you can imagine, that's not always accurate. So in the case of this analyzer, you always have an accurate vector calculation. All right, so again, it mentions here that you can make accurate coaxial stub or measuring coax. That's one of the things you can do with an analyzer. Another one is to actually find problems inside of a cable. So for example, here's a perfect example actually. Our field day, W6SFM is my club that I'm with. That's where I teach the Morse code class. That club has a field day as well, and one year on our field day, we put up our 80 meter inverted V fed with some Radio Shack twin lead. I don't know if you remember that, the UHF antenna coax. It's the foam insulated twin lead you use for your TV antenna. It works. It's I believe it's a 350 ohm resistance, so it's a nice balanced line. So we took that, we ran it into a balun at the radio, we put the twin lead up to the inverted V in the tree, we turned it on, and it was a perfect 40 meter antenna. And we scratched our heads and said, wait a minute, this is an 80 meter antenna. So we took it down and we moved the antenna length in and out and put it back up, and we had a perfect 40 meter antenna. So we scratched our heads and thought about, you know, what's the problem. We stretched out all of the rest of the length of the antenna that we had, put it back up, and finally, we had a perfect 40 meter antenna. So somebody said, doesn't anybody own an analyzer? And I said, oh, that's right, I do. So I grabbed my antenna analyzer, this RigExpert AA-230 Zoom. It has a time domain reflectometer on it. So what it does is it sends out a signal, and basically it's like a submarine ping. It listens to the signal come back, it sees how long it takes to get back, and it makes some calculations based on that information. And it also tells you by how much energy comes back and how long. If you have a short, an open, a crushed piece of coax where the insulator is too close to the center conductor, or in our case, perfectly out at 33 feet in that twin lead, we had a short. So basically what was happening is we were transmitting into our twin lead, and that was our 40 meter antenna. So after about 2 minutes of looking at that, we took the antenna down, changed the balun to the top, put a piece of coax on it, and there came our 80 meter antenna back. So had we not spent the 35 minutes taking the antenna up and down and just actually put the antenna analyzer on, in about 2 minutes we could have realized, oh, there's a problem out 33 feet and 6 inches away. And that's still inside of our twin lead. So it could have been solved very, very quickly. Believe it or not, another one of the things that you can do with an antenna analyzer like the RigExpert is measure capacitance and inductance. not only can you do it of a reactive load, meaning an antenna, where it will tell you how much reactance you have, inductive or capacitive, but you can actually measure a capacitor and you can measure an inductor. So if you have a coil that you want to know how many microhenry it is, you can measure it with the analyzer and it'll tell you. If you have a capacitor and you just don't know the value, or maybe you know the value but you don't know if it's a bad capacitor, you can put it on the analyzer and it'll tell you what the microfarad or the picofarad rating of that capacitor is, and you can check against what you believe you have. So it's 3 meters in one there, and anybody who owns a capacitor tester knows that they usually run between $100 and $300. So you're getting your money's worth just in that. I don't use it that way because I use it for antennas, but if you wanted to, you certainly could. And as you see on the screen here of this AA-230, you're measuring the SWR in a graph mode, and also you can measure reactance and resistance. All of the measurements that you see on the screen here can be imported to a computer. So if you have something, you want to make a presentation to the club, and you're making measurements, you simply plug it into your computer through the USB cable that's provided with it, and goes in the bottom of the analyzer. You just load that up, you load the software, and it gives you the ability to do all of the measurements that the analyzer is capable of doing, but on a computer, PC, Mac, or Linux. So those are some really big features that you can use your analyzer for. You could use it as a bench piece of equipment and never hold it in your hand if you just wanted it on your bench. So why the RigExpert? Okay, well, let's see here. Number 1 and 2, those are the old style circuits. These are what they call rectifier diode detectors or rectifier circuits. This is what you'll find in your standard MFJ analyzer. So again, what I was explaining is you have a local oscillator which drifts by itself as the temperature changes. If anybody, are you familiar with the big MFJ, I think they're like a 253 or
259.
259. Yeah, it's about 2 bricks side by side. When you load it up with the batteries, it weighs at least the weight of 2 bricks. In any case, what they're doing here is they have a local oscillator, they put it through a mixer, and then they take measurements at different positions of the diodes. These are where I was explaining to you the voltage measurement. There's no vector calculations, they're just taking measurements off of the cathodes of 2 diodes. And then you see that 50 ohm resistor in there. That's where they get their 50 ohm resistance measurement. So they just, the voltage, they know what the voltage should be in that parallel circuit. And if the voltage is what their preset voltage is supposed to be, then they just assume it's 50 ohms because there's a 50 ohm resistor that sits above it. So it's just a lot of measuring local oscillators off of a rectifier. So the RigExpert analyzer, which is shown on the bottom there, as you can see, it's all solid state. Well, there are surface mount devices in there. There is a bridge, a resistive bridge. That is where we do measure the real resistance, and the real resistance is set with 8 different resistors where they are very well calibrated to be exactly 50 ohms. So there isn't a single resistor that sits across 2 diodes. It's actually an entire bridge. There's 2 separate DDS circuits in here that are pulse-shaped, and they go through the resistive bridge, out the mixer, and then the CPU analyzes that and gives you your reactance and your resistance. So it's calculated in such a way that with the DDS circuits, you have a 1 part per million transmission. So you can actually use your analyzer as a calibration device too. I don't exactly recommend it, but you can use it to output a signal to tune your radio if you wanted to. You'll be within about 1 hertz. It's real close. It just depends. Every analyzer, the DDS is set up individually. And then, as I said at the bottom here, you can see the MFJs, the diode detector. An important thing about this is because they add the resistance and the reactance together and they don't make a vector calculation, on their analyzer, if you have 25 ohms of real resistance and 25 ohms of imagined resistance, they come up with somewhere around 48 ohms of impedance. Well, that's about a 1.2 to 1 SWR. So on a MFJ analyzer, you're going to see that your 25 and 25 ohms is about a 1.2. That would be great if it were true. But if you take those two same numbers and you make a vector calculation from them, in actuality, what you get is more like a 2.4 to 1 SWR. So, as you can see, the two antenna analyzers are going to tell you vastly different SWR readings with that same measurement. One is going to be correct, and the other one is going off of voltages and addition. So, the one thing I can say about the MFJ analyzer is the closer your antenna is to perfect reactance, meaning the closer the reactance is to zero imaginary resistance, the more accurate the analyzer, because now it only has to deal with real resistance, which it can measure. So the farther away the reactance is, which means the farther your antenna is out of tune, the worse the calculations on the MFJ analyzer become. Whereas with the RigExpert analyzer, you have to get to about a 30 to 1 SWR before the reactance is having a hard time calculating properly. And most of us know that if you've got a 31 SWR, it's probably because you're trying to tune an 80-meter antenna with a 40-meter wire. It's just too far away. Or your impedances are just so far off that you don't even have a reactive antenna. It's time to start rebuilding your antenna. Okay, so as I said before, there's different models. I know this is difficult to see. This is available at the RigExpertUSA.com website. If you go under the home button at the top of the page, it says Antenna Analyzer Comparison. It brings up this chart. So what this shows you is all the different models, including the AA-230, which is a kit version, and I brought that with me. I can show that to you. The AA-30, 54, and 170s are still there because people who own them currently may still want to compare with what's new. So the budget, well, how do you select the right analyzer? The first thing I tell people is don't spend more money than you've got to spend. You know, feed your family before you buy an analyzer. It just makes sense. So I never oversell anybody on an analyzer. If you tell me I've got an unlimited budget, well, I'll just tell you the next question, which would be how high a frequency do you operate? If you operate at 440 and that's your main band, well, you really don't have a choice at this point. You have to start at that AA-600, which you see covers that 100 kilohertz to 600 megahertz area at the very top there, third from the right. If you're operating up to 6 meters, well, the AA-55 is a great analyzer. So there's no reasons to go on any farther. Unless you do 2 meters, then you'll want the AA-230 zoom, because that'll cover your 2 meter section, and 220 incidentally. But the only reason that you'd want to go from an AA-55 to an AA-230 zoom if you don't operate on 2 meters is because you want that time domain reflectometer. The time domain reflectometer is what I discussed that checks the coax for anomalies and tells you exactly within about 3/4 of an inch where in the coax the anomaly is and what kind of anomaly it is. The AA-55, although it has coax tools, that's not one of the features that it has. So you really want to make sure that you buy the right analyzer for your needs. Those of you who have a 440 megahertz antenna and you think you need an AA-600, the next thing I say is this antenna mounted on your car, or is this an antenna that you've got at your home? And the reason I ask this is because 99% of the antennas that you're going to buy for your car are pre-tuned. There's no reason to buy an analyzer to check a $50 antenna that you've placed on your car that's been pre-tuned. For example, Diamond Antenna buys analyzers from me, and he checks all his antennas before he sends them out. So they're pre-tuned. Unless you've gone through a car wash and it bent it over or it's distorted somehow, you probably never need to check your 440. Another thing is, I tell people, if you're hitting the repeater on a 440 antenna and there's no static coming back and you know there shouldn't be, your antenna is probably tuned. For those of you who have an antenna that's a 440 megahertz at home, then maybe you want an antenna tuner because that'll reach that band, because you've got a Yagi, or you've got a J-pole, or you have some other type of antenna that actually requires tuning. So in that case, you do want an AA-600. But otherwise, I would say for those people, you could probably back out to an AA-230 zoom and you'd be fine. All right, so basically, we've discussed what makes you decide, how do you choose, and you can see the budget is set there, $279 to $979. That $1,400 goes for almost $1,000. So first thing I'm going to mention is, you see all these beautiful displays that I've made here. Every one of those came off of this AA-230 zoom by plugging in that USB cable to the computer. So that's what they're going to look like. You can do them just like that. So this is the SWR mode. You get SWR mode in 5 different modes and 3 different styles. So you see there are 5 windows up there. The first one on the upper left is graph mode. You see that it has made a graph with the center frequency at 14.100 or 14,100 kilohertz. Everything is made in kilohertz measurements. And it says plus or minus 1 kilohertz, or 1,000 kilohertz. So basically what I have is 13,100 to 15,100. So again, from this side of the scale, it's actually plus or minus 1,000 kilohertz or 1 megahertz. So this side of the scale is 13,100. This side of the scale is 15,100. You'll notice that there's a blue bar there. That blue bar is an indicator of the 20-meter band. So as you see, because we're going out an entire megahertz to the left and to the right, the entire 20-meter band fits right in the middle of that graph. So this graph is showing me that I have a very broad antenna because I'm under a 2-to-1 for the entire 20-meter band. And you can easily see that because here it tells you the SWR 1.0, 1.2, 1.5, etc. And I can see all within this blue bar, I never get above, it looks like a 1.5 to 1. So that's the SWR graph mode. You'll notice there's a little 1.13 in yellow right above that triangle, right next to that triangle. That's telling you the center of the graph, which is at 14.100. The SWR is exactly a 1.13 to 1 SWR. Now you'll notice at the bottom it says min 1.12, and it tells me that at 14,060 I have a 1.12. So now it's giving me 2 pieces of information just looking at it. The first thing is, whereas before with other analyzers, you only knew where the SWR was at that center frequency. On this analyzer, not only do you know what the SWR is at the center in yellow, but it's also Analyzer for Dummies because it's telling you exactly where your lowest SWR is within that entire scan. So I can now say, oh, well, I know if I'm working the CW portion of 20 meters, I can see that I've got a really nice SWR down there. All right, so the next mode there is the Smith chart. For those who know how to read a Smith chart, that should make decent sense, and it's exactly the same thing. It shows you that you have a 1.13 at that center frequency, which is the red dot, and the red dot is indicated at 14,100 kilohertz, just like this one here. So these are exactly the same thing. What can I see with that Smith chart that I can't see by looking at the SWR graph by itself? Well, if you know how to read a Smith chart, you can see that the antenna is inductive, and the resistance goes up and down depending on the frequency. So, but we can see that the antenna is never short, it's always, it's never short, it's always inductive. So I can tell immediately that that antenna runs longer. So it's more than likely not a 20-meter antenna. it's also something else, which we would find out later. In this mode here, you have multi-SWR. This mode allows you to make measurements across multiple frequencies at one time. You can do multiple frequency, multiple bands. In this case, I have 20 meters, 17, 15, 12, and 10 meters. And I'm making a measurement all at the same time. So at 14,100, this antenna was at a 1.18. At 18,118, I have these SWRs according to the frequencies. If I wanted, for some reason, instead of graphing, I just wanted to put in my favorite frequencies of 14.000, 14.050, 14.100, 14.150, 14.200, because I just happen to always turn my dial to that frequency, I could measure just those frequencies as well. So it doesn't have to be multiple bands, it could be multiple frequencies. And then, of course, the next mode there is the SWR as an analog meter. And as you can see, back to that same 1.13 reading. And that's telling you that you've got a 1.13. And it also indicates your return loss. A lot of people don't know what return loss is. It's actually a fixed number that's based on SWR. So if you know the SWR, you know the return loss. Some people need to know return loss as opposed to SWR. If you do, it's displayed there. And then finally, you have the all mode. And the all mode is everything that the analyzer can read at one time. And that is the SWR, the impedance, and we can see we're not a perfect 50 ohm impedance, and that's why it's 1.13. The return loss, which here it's actually more accurate. It's showing you that it's actually 24 dB as opposed to 25. The phase of the signal that's coming out of the antenna is shown here. So I can see I'm at 104.4 degrees. So that's pretty important, and that may have helped Phil as well, so he could see what his antenna was doing during the transmit. The resistance, the actual resistance of the antenna is 48.2 ohms, whereas the reactive or imaginary resistance is showing me that it is capacitive at 5.75 ohms, or a negative 5.75 ohms. And if you look on the Smith chart, if you know how to read the Smith chart, you can see that I'm below the center line where the red dot is, which does indicate that it's capacitive at that one point. And then it's also got inductance, and it's negative inductance because I am capacitive, but it shows you how much inductance it has in negative, and it shows you exactly that I have 2 nanofarads of capacitance. So I'm able to see resistance, reactance, inductance, and capacitance all in one shot, and I can see the SWR and impedance. All right, and I can see that this says it's in series mode. That's the way that amateur radio operators measure their inductance and their SWR. However, you can switch it to parallel mode. So if you need a more precise measurement in a parallel mode, it will do that. So these are the 5 modes and 3 different styles of SWR reading. So that's a lot for one antenna analyzer. So our next mode is the reactance and resistance. So as you see here, there's a yellow line and there's blue line. In the old analyzer, one was just solid and one was dashed, and that's where you started getting lost inside these lines. Or for example, where those yellow and blue lines crossed there, it would be extremely hard to tell which was the dashed and which was the solid, because they started intersecting with each other and the solid line would clearly swallow up the dashed line. We don't have that issue anymore. So in the reactance and resistance mode, you have it in 3 modes and 2 different styles. And what you've got here is the graph mode, which is the top, similar to the SWR. The triangle tells you your center frequency of 14.100, and it tells you again this graph has been made down to 13,100 up to 15,100 megahertz. And it tells you in the yellow to the left of the triangle at the top that that center frequency has an resistance, a real resistance of 48.2 ohms, and we saw that in that all mode, and here it is again in the all mode screen, 48.2. And then in the blue line, it says to the right hand side of the triangle at the top, minus 5.88, and then that's telling you that your reactance at that point is capacitive or negative 5.88. And then here, You can see that, again, Analyzers for Dummies tells you that at 14,326 kilohertz, you have your most resonant point. But you say to yourself, well, wait a minute, the SWR just told me that I had my best SWR at 14,060. So that's got to be where my antenna is best. Well, this is what I started telling you when we began this lecture here. The SWR is not an indication of where your antenna is resonant. Your antenna will put out its best energy at its resonant point, not its best SWR point. You can have a 2-to-1 SWR and have an antenna resonant at that spot. So here we see that we've got 14,060 for our best SWR, but our resonance is actually at 14,326. So this antenna is really tuned above the 20-meter band in actuality, or actually right at the edge, because it's 14,350 is the edge of the band. So you can see that triangle is pointing right to the edge there. So what I know about this antenna now is the resistances are off and the resonant is too high. So I need to get this antenna resonant in a lower part of the band, which means that I actually need to increase the length of the antenna to get resonance lower in the band, but I need to increase the resistance, because when I lengthen it, the resistance is going to start dropping and the SWR is going to start going up. So with the analyzer, I can tell exactly what I need to do to make this antenna good. And I can see here, it tells me, 2 places. This is, because I'm below this center line, I know I'm capacitive. Because that says it's minus 588, I know I'm capacitive. Because it says I've got 2 nanofarads of capacitance on my antenna, I know that I'm capacitive. So like I said, I know in order to get that resonance down to where I want it to be, let's say I want to be at 14,100, I actually need to lengthen this antenna. But you see what's going to happen when I start lengthening this antenna, the resistance is going to start dropping down towards this 0. So what's going to happen is I'm going to lose resistance. So what I need to do is I need to lengthen the antenna to bring this up to here, and then I need to figure out how to get my resistance up to bring me back to a 1-to-1. So with these 3 views right here, I can actually tune my antenna to perfect resonance and then work on the resistance. Or I could do them both at the same time, because I can actually keep that in loop mode, make a change, and be watching what the graph is doing. So I can see the auto marking for the top there telling me the center, and then I can see where it is resonant. So I've got all the information that I need in those 3 screens. As a matter of fact, the Smith chart tells me everything. If I knew how to read a Smith chart, I would just stick in the Smith chart and never move it. But because the graph is such an easy way to see where you are, you want to look at the graph to see your actual resistance and how it's reacting and your reactance. Now the thing about the graphing mode is you have a given amount of plots, meaning the analyzer can only make so many plots. So for example, on the AA-35 and the AA-35 I believe is 80 plots and per measurement, and the AA-55 is 100 plots per measurement, and the AA-230 can actually be adjusted so that you can check up to 500 plot points. So if I set the AA-230 to 500 plot points per graph, and I do 1 megahertz, I'm going to get a plot point every 2 hertz. And that's a lot of plot points to make. So in this case here, this is an AA-55, so I have 100 plot points. I've gone plus or minus 2 megahertz. So within that 2 megahertz, I only have 100 plot points. So the accuracy of the analyzer can be greatly increased by making your graphs smaller bandwidths. So in this case, maybe I might take a quick snapshot because I want to see where my antenna is tuned. So I made a giant 2 megahertz sweep. But in the case that I know that my antenna is pretty close somewhere in this first section of the line of the 20-meter band, maybe I would make my measurement realistically from 14,000 to 14,100. Now I've only got 100 kilohertz and I've got 100 plot points, so I've got 1 kc for every plot, which is plenty enough, and the accuracy will go up, because instead of having to draw a linear line from plot point to plot point, it's like a dot-to-dot drawing where you have these limited amount of plot points. If you've stretched it out over a certain amount of time, the linearity of the plot is going to be different than if you squished it together and you had lots of plot lines and you're moving along real close together. So that's why you might see, for example, where the number, let's go back, let's see, where was it? The number here, for example, was a 1.18, and here it was a 1.13 for the same frequency. Well, that's because this analyzer is making an exact measurement here. It's making a plot point perfectly there, whereas maybe that plot point is off by 20 kilohertz or 50 hertz or something, and that the increase was so quick at that point, it just skipped over that measurement. So it's possible that because it was such a wide bandwidth, it did that. So let's go on to the next thing. So that was reactance and resistance, a great plotting measurement tool. All right, so the next one is that all measurements, as we already discussed, and in this all mode display, you see the return loss that I discussed, which tells you about 24 dB of return loss. It tells you the line phase, the inductance, the capacitance, and then it'll also make a graph of return loss. All of the analyzers will do a return loss graph. The AA-230 is the only one that has it as a menu choice. The other two, 35 and 55 analyzers, you can get there through the, you can't get there directly, you have to go through a menu. But it will make a graph, just like the SWR graph and the reactance resistance graph. It'll make one for return loss as well. So if all you wanted to see is return loss in a graph, you could do that. And then the other thing is, with the AA-55 and the AA-230, you can also recalibrate this analyzer. We call it an F2 toggle, and the reason that you might want that is, say you want to measure your antenna at the feed point of the antenna, but you don't want to include the 300 feet of RG58 that you just have hooked up to it to the station. So what you would do is you would put a load, an open, and a short at the end of the coax, and you would recalibrate the analyzer to exclude that piece of coax. So basically you're zeroing the analyzer's calibration with the coax attached. Now when you hook up the antenna through that coax, the coax is ignored in the equation that the analyzer makes, and all of your measurements are exactly at the feed point of the antenna. That's really important for someone who's designing antennas, because they don't want the antenna to include the calculation of the coax. So for example, if Diamond Antennas made a calculation and they included the coax, when you get the antenna, your calibration of your antenna may be wrong, because maybe you use a 25-foot piece of coax, and the guy at Diamond is using a 3-foot piece of coax. So he excludes the coax out of there. The great part about the zoom analyzers, the 55 and the 230, you push the F key and the number 2, and it toggles back to the original calibration, and you haven't destroyed anything, and you don't have to worry about sending your analyzer back in to be recalibrated. You can just toggle back and forth. It's really helpful. It's not available on the AA-35. That's one of the features that you pay for on the AA-55 for the price difference between that and the 35. All right, so toggle mode calibration, really nice. I also tell people there's no real need to do that recalibration to exclude the coax for most people, because your antenna and your coax are part of your system. So you really want to tune them together, because you really are using them together. If you tune your antenna perfectly and then hook your coax up and it messes everything up, well, other than reactance, it doesn't really matter. All right, so here are the coax tools. These are new additions to the analyzers that were never available in the older models. These are available on the 55 and the 230. They're not available on the 35. That's another one of the features that you get when you upgrade from a 35 to a 55. So coax tools are stub match tuner. This is a great instrument. So this piece of coax, when Phil was in here, he wanted to know how long this coax was so that he could calculate the quarter wave and half wave stub match for it. Well, it's not necessary anymore. Now all he's got to do is plug this cable into the analyzer like I have here, hit go, and then it will measure the coax and it'll tell you that it's 7.822 megahertz for a quarter wave and it's 15.907 megahertz for a half wave. And it tells you that the cable has an open on the end. If you had a short, it would tell you had a short. If you have a load on there, it'll tell you have a load on there. Now, according to this piece of paper, Phil marked his thing. He made a test, and he says that with his calculation, his AA-230, after doing all the calculations, said it was 7.829 megahertz. So he got real close, 7.822. And then with the another brand that was a vector network analyzer, I think it was the Mini VNA, he got 7.800. And then it bounced to 7.814. So it was all over the place. And as you can tell, it's not as accurate. And then he has a 3A analyzer, and it came up at 784. So it was nowhere near it. So both his AA-230 and this AA-230 Zoom both agree that, you know, we're within 20 hertz of where that cable is tuned. Now the great thing about the stub match tuner is you keep that going, it'll continue to send RF. So if you needed to raise that frequency, you just take your dikes to the coax cable and snip, cut it, and it'll instantly tell you where the new frequency is. So if you needed to keep going up to, I don't know, to 7.9 for some reason, then all you have to do is keep clipping the coax and watching the number as it goes up. So it's going to tell you that. The next coax tool is the length and velocity factor. This is a great one. If you know the velocity factor of the coax, which most people do for their coax, this coax here is 0.66. That would give you your RG-213 or an RG-58. If you know that, you just the preset is 66, so it'll stay there. And then when you hit go, it'll tell you that the cable is 20 feet, 7.74 inches. So 20 feet and 3/4 inches, basically, I guess is what that's telling me. And I'm guessing that that is going to match this stub tuner as well. So it tells you exactly how long it is. Now, if you have a piece of coax and you really want to know what the velocity factor of the coax is, say you have a 10-foot piece of coax. You know it's 10 feet, you've measured it, and your tape measure is accurate because you haven't stretched it out. You can put in exactly 10 feet, so 10.00 here, and then hit go, and this number here will actually change and tell you the exact velocity factor of the cable. So you can tell the velocity factor or the length of the cable in that menu. The next one here is cable loss, and in cable loss what it does is it measures the cable from 600 kilohertz, or rather 60 kilohertz, all the way up to 55 or 230 megahertz. In this case, it's 55 megahertz, because this is in the AA-55. And as you move your cursor here, there's arrows that move left and right on the analyzer. As you move the cursor to the left or the right, it tells you the frequency that you're at. So in this case, I'm at 27.5 megahertz, so 27,500 kilohertz. And it tells me that at that point in my coax, I have a 0.29 dB loss. So if you go to the swap meet and the guy tells you, this is the best coax in the world, and you stick your analyzer on it and do a sweep, and all of a sudden, you know, you've got a 1 or 2 dB loss at the frequency that you want to operate it at, you know you got a bad piece of coax there. Or maybe the coax has been sitting out in the sun for years and it's getting lossy because UV is going to damage the coax. It will get through into the center conductor. If you have a foam insulation like an RG-58, then you're going to get damage to that foam after so many years. So you can monitor this and save that into the memory, and you can actually check it against the new measurement in the next season. The analyzers all have memory so that you can save all of the graphs and all of the measurements. It's something that you can use for seasonal measurements, something after a storm to make sure nothing's changed, or just to keep an eye on your antenna and your system over years. So in this case here, this piece of coax, you can see it's pretty good at it's pretty good at the lowest frequency. So this is clearly going to operate really well in that HF portion down here. So up to probably about I'd say 15 meters, this coax is pretty good at 0.25 dB loss. That's actually really low. Most coax you're going to find between 0.5 and 75. And then the final measurement here is impedance. So this is the overall impedance of the coax. Guy tells you at the swap meet, this is the finest American-made coax you can buy. You plug it in, the first thing you saw was, wow, that's really lossy. But the next thing you'll see is, do you really have a 50 ohm piece of coax? Well, I do from here to here, and I can see that my center frequency is telling me at 27,500, I've got a 51.8 ohm piece of coax. Well, I wonder what that frequency is, because I sure hope I'm not operating there. Because if I am, I've got about 25 or 30 ohms of impedance on my piece of coax that's supposed to be 50 ohms. If you have a cheap piece of Chinese coax, I can almost guarantee you, you're going to see your coax up here. Most of this stuff that comes from overseas is anywhere between 58 and I think the highest I've seen is 72. And that's sold through places like DX Engineering or HRO. They're letting that coax out the door because people want to buy by price, not by quality. So you get a piece of inexpensive coax and you're going to see that your impedance is way up here at 70. That's not good because your radio wants to see an impedance of 50 ohms. So that's a bad thing to see something like that. But this analyzer will tell you the stub match, it'll tell you the length, it'll tell you the velocity factor, it'll tell you the loss over the entire frequency range, and as you move that cursor, it'll tell you the loss and the impedance of the cable where the cursor is parked. So those are really helpful coax tools. Those are available on the AA-55 Zoom, the AA-230 Zoom. The 35 does not have the tools. And then finally, I talked about that TDR measurement when I checked that twin lead coax. Here it is. This is what a TDR measurement looks like. In this case here, I see that at 9.17 feet, I have a short. That's what that tells me. If this antenna was an open, you can reverse that. This yellow line would shoot up, come back down, whereas the blue line would shoot up with the yellow line, but it would stay continuous at the top at the 0.50. So this is a perfect short. So, and it tells me that that coax is 15.52 feet long, and at 9.17 feet there was a short in it. It tells me that there's an anomaly here at 2.82 feet as well. So that was probably the adapter on the cable. It's very sensitive. It measures any impedance change at all. That means that if you have an adapter on the top of the analyzer, it sees that it's there, and it's going to mark it and tell you that there's a problem. But at 9.17 feet, I see I have a short. So this is the time domain reflectometer, and it tells you when you have faults. Now, if you didn't have a perfect short, and you just had maybe somebody drove their car over your coax while you were in the garage working on the antenna, and somebody came home and drove over your coax and crushed it, but you don't see it because it crushed the inside, the insulator, not the outside of the coax. Well, this line here may just kind of squiggle around a little bit, and maybe it'll recover itself, or maybe it'll just dwindle out here and then just fall down as loss, because it'll just keep going down as loss over time. But if it's just a damaged piece of coax, at that point, maybe the bird's been pecking at your coax up on your tower. I had a guy at a radio station call me the other day, and he wanted to know how to read the time domain reflectometer properly, because he kept getting his antenna, kept telling him his coax was 330 feet long, but he promised me that his tower was 500 feet tall. So first thing I did was I told him to shake the cable and see what it does. So he did, and actually the SWR was all over the place. So I know that he had a problem with the coax in the first place. But what happened was he had a bird pecking at the coax, and he had to send somebody up 300 feet up his tower to put a coupler on, and sure enough, that's what he found was the bird pecked at his coax. But with this, he never had to get off the ground, which was good because he was 72 years old, and he didn't like to climb towers anymore. So for him, he was happy to send one of the guys up the tower. So this is a great tool for checking coax. That's available on the AA-230, but it's not available on the 55 or the 35. As I mentioned before, you see these blue lines here? Each one of these blue lines represents a band for the ham radio. So that would be 75, 80, 60, 40, 30, 20, 15, did I miss something? 15, 17, am I missing something? I think I'm missing something. 15, 24, I missed 20. Now I'm so confused. Anybody who knows me knows I have terrible memory. I know that's 10 meters, look how wide it is. But yeah, so you have your 80, 75, 80, up to 10 meters here. So each of them are marked in bandwidth. So this is again the 55 zoom, so it only goes to 55 megahertz, and I didn't spread it out wide enough to show the 6 meter band. But if I had, 6 meter band would have been way over here, because this is 28, well that's 27, so that is 6 meters then. That's the 10 meter band, that's 6 meter band. Because if that's 27 megahertz, then all the way out here would be 50. So yeah, that's 6 meters up there. So then 6, 10, 12, 17,
15,
oh, 15, 17,
20,
20,
30, 40,
40,
60,
60, 87. That can't be 60, 75. There's something in line.
yeah.
I missed it. You can check it when you buy it. But you get the idea there. So they're all marked, and clearly as you increase decrease the bandwidth and zoom in, you're going to have that blue line throughout the entire display because it'll tell you that you're within the ham bands. These band plans are changeable. So if you happen to buy this analyzer and move to a foreign country, you can change the analyzer in the menu to a European standard, for example, and all these lines will move according to their band plan. And you say, well, what happens when the, IRC? The IRC2 says that we get a new band plan. What then? Well, you update your analyzer, and it's in there. And instantaneously, you have all new lines in the right place. So if there's any changes, you get them. Why do they call it a zoom mode or a zoom analyzer? Well, we have a thing called zoom. So what you see here is that's the 20 meter band, and I've obviously now zoomed into the 20 meter band. It tells me my center is 1.23 SWR, and I'm at 14,175, and I'm 500 kilohertz wide, so that's why it's almost got the entire band. The zoom analyzer allow you to zoom in both in bandwidth and in value. So for example here, you can see that I have zoomed into the band from where it was at 250 kilohertz. So now I am only looking at 100 kilohertz in area. So I wanted to see what the reading was at this spot. I didn't have to take a new graph measurement at that location and zoom into it. Instead, I have my measurement made all the way across the band, but I'm interested to see with more detail here what it is. So without changing the SWR value, I just simply zoomed into this area of bandwidth. So now I have a much better view of where my SWR is for that frequency in plus or minus 100 kilohertz as opposed to 250. Now, the other zoom mode that you have is you can zoom in and out of value. So you see at the bottom of the scale you have a 1-to-1 SWR, and at the top you have a 2-to-1 SWR. Well, that's helpful if I've got a 3-to-1 SWR and I need to see what's up there, but I can't because the line shoots off the screen. Well, I can zoom out, and you see here I can now see a 10-to-1 SWR, and I can see I'm well within 10-to-1 SWR. So I've not only chose to zoom out farther, because you see I'm at 500 kilohertz now, but I've also changed the zooming on the scale. So now I can see the entire 20-meter band at a blink of an eye, and I can see SWR up to 10 to 1 SWR unit. So it gives me the chance, if I started here, I can zoom right into an SWR reading at that frequency there and get more detail. So maybe I couldn't tell where that was on the screen because it wasn't, that wide. I only had a screen this wide. So because I couldn't see that, maybe I wanted to zoom in real close, and now I can very easily see that it's touching the 1.2 to 1 line, or just how far is that below the 1.2 to 1? Well, I can see just how far it is below that 1.2 to 1 line. So that's zoom bandwidth and zoom level. These are things that couldn't be done on the other analyzer. In order to do this before, you had to set the center frequency, set the bandwidth, do your scan, read your analyzer, and then say, okay, now I know where my best SWR is because I can see it's way over here. And then you had to move the cursor over to that location and then lower your bandwidth and then do another scan. So that's no longer necessary anymore. Now you can simply zoom in to where you want to be and zoom up to the level of SWR that, or resistance reactance, same thing. You can zoom into those values. Now, once I've zoomed in, as I have on the top screen here, maybe what I'll want to do is make a new graph. Because remember, you see here, yes, we'll update you later. You can see on there that I've scanned a very large portion of the band. I mean, again, we're out pretty wide. That's our 2 megahertz, I believe. So, again, I only have 100 plot points. So I'm at, 50 hertz per plot. So if I want more accuracy, I'll zoom in like that. And if I like, I can just make a new scan. And it'll rescan it again, but now within that area, zoomed in, this would be a better example. I've zoomed in the bandwidth. Within this area here, now I will have my 100 plot points, as opposed to having 100 plot points along that whole area. So I can zoom in and focus on what I want, and then do a new scan, and I'll have all my 100 plot points within that new scan. So that's the zoom feature. It's actually really incredible when you're out in the field and you're just trying to look at your antenna to see where it's tuned and if it's tuned at all. Maybe I'm tuned way outside the band. You put it up like that, and once you find where it is, you can zoom right in on it. All right, so I told you this can connect to the computer. You saw all those beautiful graphs and screenshots of the analyzer. Well, this is how you update the antenna analyzer itself. So it tells you your device serial number. It tells you the revision of the analyzer hardware, and it tells you what your current firmware version is and what's available to download. And you see you can just upload it or update it from the internet. So you simply click that and click next, and it just does it. And then it'll reboot, and when it reboots, you'll see that you have version 117 in your analyzer, which I believe we're at 118 for this analyzer now. So updating the antenna analyzer is as simple as plugging in the USB cable, running this little flash tool that takes about 30 seconds to download, and then updating the analyzer on the internet. So there's no more downloading files, going into programming mode, and then knowing which COM port you're on, typing it in, and then hitting go and waiting about 2 minutes for it to update. It just does it, and when you hit finish, it closes that window and reboots your analyzer. So updating is simple as pie. All right, like I told you, RigExpertUSA.com. That's the best place to get your analyzer. You can buy it at PNCengineering.com. Doesn't matter, it's the same thing really. Because when you go to RigExpertUSA.com, the only thing RigExpert USA sells are refurbished analyzers. So if somebody bought an analyzer and returned it to the store because they decided they didn't want it, there is a return charge, but some people, they realize they spent more than they should have, so they return it. Very rare, but I do see it from time to time. Maybe it was under warranty and something happened and they returned it, and it gets repaired and then it goes to the refurbished store. So RigExpert USA really only sells refurbished. When you click on the Buy Now on any of the new items, it will bring you to the PNC engineering site. So don't get freaked out. We're not hacking their site. They drive all the traffic over to PNC engineering because we're the distributor for the country. All right, so when you buy from PNC or RigExpert USA, you receive free telephone and email, technical and operational support. You can also go to the RigExpertUSA.com site and click on the chat button, and there's 3 people that'll answer, Bob, Lynette, and Marcus, and they'll check your name in the system, and if they see you're a customer of ours or theirs, then they'll give you all the time you need. They'll answer every question. If you say, I don't remember how to do a RX graph, or how do I zoom in or out, you know, anything you need to know, you ask them, and I guarantee you they're going to have an answer, and if they don't, they're going to find it out for you. All right, with us, you receive a 2 full-year warranty based in the United States. When you buy from HRO, they get their analyzers from Canada. If you have a problem, they tell you to ship it back to Canada. I don't know if you've shipped an analyzer or anything else to Canada, but you ain't getting it to that country for less than 28 bucks. So after the first 90 days with HRO, that's it. It goes back to Canada. I don't want to speak badly about other places, but there's 2 other vendors where they won't even answer your email if you have a problem with the analyzer, and I end up helping those people. You can find it on Amazon. Don't buy it there. You will have no warranty on Amazon. People buy things on Amazon, they break them, they transmit into the analyzer, burn out the entire detector circuit, and then they pack it back in the box and ship it back to Amazon. Amazon will gladly take your returns, and then they sell them to the next guy. So we do not warranty Amazon purchases because people abuse them and return them, and Amazon illegally restocks electronic goods that have been operated. You're not even allowed to sell it as new anymore, but they do. eBay, don't buy it on eBay because eBay, they may claim to be a dealer. They're not. There are no dealers on eBay. As a matter of fact, there are no dealers on Amazon either, although Gigaparts sells on Amazon, but it is not warranted because of the first reason I gave you. But the second reason is also because Amazon stocks their items, not Gigaparts. So you're not buying it from Gigaparts, you're buying it from Amazon, sponsored by Gigaparts. So be very careful, that's why I warn you. The other thing is, with Gigaparts, you get a 1-year warranty, and they'll sell you an upgrade if you want to spend another $45 or something in order to purchase the second year. We give you the second year. Let's see, okay, yeah, there you go. You may have to send it to Canada or the Ukraine. I've actually had a few people buy on eBay, and I tell them, sorry, this is gray market stuff, it's coming in from outside the country. You get to spend $78 to ship it back to the Ukraine, and you can wait your 12 weeks to get it back. So, actually, to be honest, what will happen is you'll still have to send it back, but I'll end up taking care of it anyway. But the thing is, you're going to wait about 12 weeks because they'll ship it back to me, and then I'll end up shipping it to you. Okay, so lowest price guaranteed. Yeah, we all do. And then we take PayPal, debit card, credit card. So if you want to pay by any of those, a lot of people like to pay by PayPal. It's real convenient, and you can hide it from your spouse. So those are my suggestions. And I don't know that I have any more slides. Let's see. Yeah, that's it. So again, I have some analyzers here. I'll wait till the meeting is over, I guess, and you guys can come on over and poke around on this AA-230 Zoom. Thank you, Bob. You can poke around on this AA-230 Zoom that I have. I've got a piece of Coax that Phil loaned me to test this.
Here's an antenna if you want to try it.
Oh, we can, yeah. Have you checked it?
2 meters if you want to try it.
Did you tune it on your VNA?
Yeah.
Okay. What did it tell you?
It's around 146.
Okay. So Carol has an antenna here. It's a loop. I guess it's a mag loop.
Oh, wait a minute.
You have
got an end connector on
there.
there.
Yeah, you did. I was going to say. It's,
Now it's a BNC.
That's okay. I have a BNC down here. Matter of fact, I can have one. Oh, you know what? I could have used that. Let's put that back on.
Okay.
Here, let me, because I forgot this analyzer.
230, is that a UHF?
Yeah, it's an end connector, but when you, oh, that's something else I forgot to mention. Bob, can you hold your analyzer up? Bob bought a 230, and you see that pretty case that it comes with there? We supply $35 worth of accessories for this model. You get a SO239 to N connector adapter. These analyzers are real analyzers. They don't have PL259s on the top for the AA-230 because once you get above a certain frequency range, it's no longer accurate and you shouldn't be using it. So technically speaking, all of your antennas in your cars should either have a BNC on them or they should have an N connector on them for that UHF stuff you're running. You should not have a PL259 on it. You're getting tremendous loss through impedance mismatches. So I would suggest that you snip it off and put an N connector and then figure out how you're going to get the SO239 on your radio because you won't be able to. All right, so I don't do that. Okay, so Carol has her antenna and we just said, let's take a look and see what it is. So Carol will hold that up. I turn on the analyzer and then the first thing I do is I'm going to go to menu number 3, which is the range. And I'm going to say, well, we know that this antenna is somewhere in the 2-meter band, so I'll say 145 just for the sake of it. All right, and then we'll sweep it for 1 megahertz wide, and now I just hit number 4, which is the SWR, just to see, and then it draws me a line right here, and assuming that nothing is interfering with her antenna, I see that according to the analyzer, it was better down at the bottom area here. So it tells me with that little triangle at the bottom that the minimum SWR was a 1.49 at 144 megahertz. So a little tuning might be necessary on this. So now here's what I'm going to do. If I wanted, I can zoom out like that, but I only made a measurement starting at 144, so I can only see what I've told it to measure. So what I'm going to do is I'm going to move the cursor over so that the beginning of the band, you see what I did there? I don't know if you can see it, but I moved the center of that reading over. So I'm moving the center of the meter to the beginning of the old scan, and I'm going to just make a new scan. Now it's going to go 2 megahertz wide, but it's going to make the center that point that we measured before. And now you see the minimum is showing over here because the little triangle's there, and it tells me I have a 1.27 at my lowest at 143.58 megahertz. So even with Carol's precision crafted loop antenna,
It moved.
it moved.
Yeah, but I can return it here.
Okay, so she's going to turn the cap on
Okay.
it, and then we're going to hit
Bring it
another
up.
scan.
Okay, I brought it up a little.
All right, so she says she brought it up a little. Now, of course, that was her touching it. So I don't think she brought it up high enough, but I'm going to do this. I'm going to say, let's just put it on loop. Remember I told you it would
Yeah.
continuously scan? So what I'm going to do is I'm just going to let it scan. Well, she did something,
I moved it way up.
but I think that
Moved
she
it too far.
maybe too far, yeah. So it's still scanning. You see it still going. It's just going to repeat itself 2 megahertz. And I think you need to go way back where you were. You're a little,
Yeah, I moved it too far.
much too far.
It's coming down.
Okay.
Oh, I think we got it. Let's see.
Okay, now that's good because you see, remember I moved it over and I moved it way down to 143. So I'm going to go back. Hang on, don't go too far.
Oh.
Whoops, pushed the wrong button. So what I'm going to do is I'm going to move my center because she's done something up here. So I'm going to move it to 100 and we'll go to 145 again. So I'm just moving it over to 145, 0. All right, well, we'll come close for time's sake. So, okay, so we're still a little low.
I'll bring it up.
So she's going to bring it up. Now I'm not in loop mode, so, but look at that. It's somewhere. It's
Try
going
it
to be
again.
somewhere where we need to be. So we'll run it again. And look at that. Look at that. Look at that.
Yeah, it looks good.
Yeah. So it tells me that at 144.82 megahertz, we have a 1.13 to 1. But let's find out if it's reactive. So I don't need to make a new scan. That's a great thing. All I got to do is hit number 5. Bink. And now I can see my resistance and my reactance. Well, I can see that this antenna is very reactive for the entire portion of the top part of that frequency there in the green line. It's showing me it's reactive. And then the top line is showing me my resistance. And it tells me the 50 ohms is right up here. And that means that it's 50 ohms right there. And it's pretty reactive there. So I can see by this measurement that I've got 50 ohms and 0 reactance at, and in this case, I think the SWR actually may match the reactance point on this antenna. So I'm doing another measurement. All right, so 144.76 is her resonant point. And now I'm going to switch back over to the SWR. 144.82 is her SWR lowest point. So what that tells me is the resistance is slightly off, but the two pieces of information are telling me that they're very close to each other. So you see here's the SWR, that little triangle is telling me my resonant, or my best SWR, and then this little triangle is telling me my resonant point. And they're real close on the screen to where the two are matching. I wouldn't even bother to retune at this point. It's anything under a 3-to-1 in most cases. If you have reactance, you've got a good antenna. Because the loss that you're going to incur depends on the coax. The worse the coax loss is, the higher your loss overall will be with SWR. If you have a very low loss cable, like a twin lead or a ladder line or open line, you know, you have like a 0.1 dB loss, and you have a 3-to-1 SWR, your SWR will only be like 0.4 dB. So it's still so low, it doesn't matter that you have a 3-to-1 SWR. That's why you don't worry so much about SWR as much as you worry about reactance being perfect. You want that resonant point. All right. Now, what else can we measure? We can look at the Smith chart. And if we look at the Smith chart, you can see all those fancy squiggly lines. It's just telling me that the antenna was very capacitive, and then it came into reactance. And again, that's a matter of reading. One of the other things that I didn't show you here was, you notice this is blue. I keep it blue because I like it during the daytime. It's real easy to see outside. But if I wanted, I could go to setup. I could change the language. I could change the color of the screen. So let's say I wanted a nice fancy orange like you saw in those drawings. Now I've got a nice fancy orange and black screen. So, you know, kind of consumery looking. It's easy on the eyes. Yeah.
When you're measuring a piece of coax for loss, it comes up with, let's say, a 0.5 dB loss. Is that for the length of coax or per 100 feet?
The loss is measured by frequency. So as you saw how I moved the cursor over to the left and the right with the arrows,
right,
I would sweep the loss from the very beginning of the measurement to the very highest frequency.
Well,
so I can see the loss. Let's go look at that real quick. Where was that? Oh yeah, it was two coax tools. Okay, so, all right, so you see here where you've got the loss. To answer your question, this is the frequency, the lowest frequency, in this case 60 kilohertz. This is the highest frequency, in this case 55 megahertz.
yeah.
I move this triangle, that's my cursor. I move it using the arrows on the analyzer,
So
left and right.
It's just for the length of coax that you're measuring.
Oh yeah, of course.
Oh, that was my question.
Yeah.
Oh, okay.
Yeah, it's only measuring what you are measuring.
Gotcha. Okay.
So if you have a 10-foot piece of coax,
Yeah.
the loss is based on that 10-foot piece of coax.
All right.
But if you know your station coax is 100 feet to your antenna, and you can disconnect it and check it, it will tell you. If you have a load on the coax, I imagine it's going to give you a different answer. Let's find out. So what I'm going to do is, I'm going to go into the coax tool, and all I do is, I'm going to actually set you back into blue here so that everybody can see it. So I'm going to go to the menu, and in the menu I go to Tools, which is the last thing down, and then I hit OK, and I'm going to go to Cable Loss, which is there. Okay, so now what I'm going to do is I'm going to take this 50 ohm, this is just a jumper for no reason, 50 ohm terminator, take it off. Now I do have a connector on the end, but it shouldn't affect it too much. I don't believe that this is the most expensive coax, so I don't expect it to be a great number, but so now I'm in that cable loss, ready to run it. So I hit OK, and it tells me connect an open circuit cable to the antenna connector and press start. So I'm going to do that. So you see what it's doing now is it's sending the signal through the cable, it's measuring the loss in the cable, and it's sweeping from, in this case, all the way to 230 megahertz. And that's it, it's done. So now it tells me put a short on it. So now it wants to see a short. Hey, now I know why I brought this. So I take this little jumper here, And in this case, I think I'm going to take this adapter off because it's easier. I don't want to short through this entire wire, so I'm not going to do this because that's a short, but it's going to include this, and I'm going to have really high, high losses in this little piece of cable. So what I'm going to do is I'm going to grab across that center conductor to the shell of the cable. So now I'm just shorted right there. And now I'm going to hit go. Now I suppose I really couldn't do this test with the 50 ohms because you couldn't test it unless you climbed your tower and shorted it too. So now, oh wow, that's pretty bad. So as you can see, this is what cheap coax looks like.
Cheap?
It's pretty lossy. I mean, my smallest one, oh, and then to figure out the frequency, you see all I have to do is move the cursor over, and you see it moving there? And it's telling me the frequency down here where the cursor is set. So in this case, I moved the cursor over to this giant bump. Let's see what it is. So in this case, I'm okay because this is 0.62 dB loss at 71.3 megahertz. Now, but let's see what it's at 2 meters, because this is a pretty common coax that you guys might use on your 2-meter radio. So I'll go over to 144 megahertz because this analyzer can do it.
How long is that coax?
We can measure that too. We'll find out. It's probably about 6 feet or 10 feet. So at 100 and let's say what, 147 megahertz. At 147 megahertz, I have a 1.02 dB loss. So that's like a third of my RF being transmitted is being burned up by this coax. So I have a 1 watt radio. I've got less than a 2/3 of a watt going to the antenna. And then I've got to worry about my loss in my antenna. So, clearly you're going to be putting out less than a watt by the time it's over if your antenna is not tuned. So now you wanted to know how long this cable was. So, well, just looking at it, I'd say it's 10 feet maybe. So what I'll do is I'll now go back to the tools menu and I'll go to length. And I'll make the assumption that it's 0.66 for the velocity factor because this is standard RG6 or RG8. Yeah, RG8U. So knowing that, I'm just going to hit go and I'm going to go out and collect it. Oh, now I have a short at the end, so I guess it'll, if it's still there, I don't know, I think it looks like it came off. But if it didn't, it'll tell me that it's got a short on the end, and we'll see. So I believe, 8.94 feet. And it tells me, it doesn't tell me I have a short. So I guess it's popped off. Yeah, it came off the center. So let's see, just out of curiosity if it will tell me I have a short. I imagine it'll tell me. Let's see if it affects the length of the cable. So I just hit go again and it says, yeah, so it's shorted out, so it's telling me this cable is 847 feet long. So clearly it doesn't like that. So we don't short the cable, and it didn't tell us to short it. So I'll collect it again, and again it says 8.93. So it's within, 0.3 of an inch in length. Now, is it? Well, maybe it is. I mean, that 9 foot, yeah, that makes sense, 9 foot cable. So it means that somebody probably cut the end and said whoops and cut it again, but who's going to know that I messed up on the connector and re-added a new connector, So maybe it got shorted twice. So maybe it started at 9 feet and now it's 8.9 because somebody messed up the connector and cut it and started again. Who knows? But yeah, I don't have a tape measure, so I can't actually measure that. Now, just for the sake of it, this would be what, about a 10 meter? Somewhere around a 10-meter antenna. So what I'm going to do is I'm going to go out of here and I'm going to go to the stub tuner menu and I'm going to hit go, and what does it tell me to do? It says put an open or a short at the end. And now it goes out. It takes just a minute to calculate. And I will say this, because this is a 16-bit analyzer, it's just slightly slower than the the 35 and the 55. The 55 just go beep and it's done. I mean, it's fast. It's real fast. So this one also goes up to 230 megahertz. Yeah.
Yeah, on that similar point, what kind of, you said it has the ability to save these things to memory.
Yes.
How much memory does it have, and is it going to ever say, haha,
Yes.
you're running out?
It does. So what happens is each analyzer has different amount of memories, and that's indicated here at the bottom, I believe, somewhere, I remember. Okay, so, excuse me, the 30 has no memories, the 35 has 10, the 54 had 100, the 55 has 10, and the 170 had 100, and the 230 has 100. Now, here's the thing about that. It's kind of misleading, because when you make a scan and you save it, let's say you make an SWR graph and you save it, you are not saving the SWR graph. You're actually saving the SWR graph, the resistance reactance graph, the SWR at the entire measurement, the reactance, the resistance, the impedance, all of that gets saved. So you don't need to make a graph for SWR and save it as one memory, and then a graph for RX and save it as another. So really, you only need to make one save per antenna, or per time that you want to check your values. Because when you load them, you can load back all of the different things, the reactance, resistance, and SWR. They're all going to be available. The all mode that I showed you, where it gives you everything down there, that's a live measurement. It won't recall it into that window. It would recall it into the graph modes, resistance, reactance, and SWR. But if you bring it back to the computer and you plug it into the computer, everything that you can do on the computer, you'll be able to get access to from the memory. So you can take that, and in actuality, if you plug it in the computer, you have unlimited amount of memory, because you can save it here, bring it to the computer, plug it in, download it to the computer, save it on your hard drive, and then use that memory slot again. When you put a memory in, you name the memory. So they all have numbers, 1 through 10 in this case, 1 through 100, and you name it. So you can say 80 meter vertical, or wouldn't that be nice? 20 meter dipole, or Yagi, whatever you want to name it. You name that memory slot, and then when you bring it to the computer, it'll be there, or when later on you go and look to see, it'll tell you. So this tells me, just incidentally before I move on, 35 megahertz exactly for a half wave, and 18.151 megahertz for a quarter wave. So this is a perfect quarter wave antenna for the high end of 17 meters. So maybe we'll string it up someday, and that'll be our next thing. Can we make an antenna out of a piece of coax? Which you can. Trust me, I made a perfect 40 meter one.
I mean, if you read Jim, you can actually do a vertical.
Sure, you can strip this down and separate the braid from the center conductor, and you'd have a perfect vertical dipole. So it does work. It's if you ever need an antenna in an emergency. I was just telling you about something, and so when you're in the graph mode, if you wanted to load something out of memory, you just push the load button, and then you see here it says 80 V dry. So I must have measured an 80 meter vertical, or 80 meter V, inverted V, while it was dry, because I wanted to see the difference between that and after it rained, because I wanted to know if my antenna was being affected by the wet branches in the tree. So I saved it before the rain, and then I did another measurement later after the antenna was soaked in water overnight. So if I want to recall that, I just highlight that one, which is number 1, and I hit OK, and there it is. And now it's showing me the SWR. I had a 1.87 at 3.66 megahertz. So not bad.
My field antennas either use lateral line or twin.
Yeah.
What about that 600 as well? But I don't.
The 55 will do
Coolers do you
impedance.
have, they would attach to that?
Well, you could do it two
Where do you
ways.
buy it?
All right, this is the one time that I would say you can buy MFJ. They make a box All it is a toroid with wire around it, and it doesn't have to be terribly accurate. It's like it's just a balun, and basically you plug your ladder line into it, and then it plugs into a PL259, and that just impedance matches it so that you could, it's a 1-to-1. So the impedance will remain wherever your ladder line is, but it will couple it from unbalanced to balanced. If you want to remain in a balanced mode, you can get one of those BNC to banana jack, and you can plug your ladder line into the banana jack and then plug it here. The AA-55 zoom, as I mentioned before, if you look up here, you'll see that the 55 zoom has 25, 50, 75, 100, 250, or 150, 200, 300, 450, 600 ohms. So if you have 600 ohm ladder line, you can plug it right in there and it'll read it natively. So it'll tell you if you have a 50 ohm antenna on a 600 ohm ladder line. The other ones you notice, they don't do that yet. There may be a version 2 of the 230 that adds it, or not sure. It could just be a software update, because I can tell you that about 3 weeks ago, those impedances weren't there. And also, I can tell you that the ability to change to 500 plot points 3 weeks ago didn't exist on this analyzer either. So that was something that was just added later on. So features, it's like buying an Elecraft radio. Someone says, hey, we could really use an audio peak filter. Well, you know, 2 weeks later, Wayne writes an audio peak filter and everybody has an audio peak filter now. So features are software definable, and they get added according to what the hardware can do, of course. So there are some things that the hardware isn't capable of doing. But in this case, those types of things were added through firmware. And it's free, and they keep coming for the life of the unit. And I wouldn't worry about the stability of the company. You know, even when they were being invaded by the Russians, I was still getting analyzers shipped to me overseas. I never had any stops, breaks, or shutdowns at all. They never stopped answering their phone or stopped answering email. It continued on from day one, 10 years ago when I started working with them, to right through their little incursion that they, you know, their skirmish that they got to today. So they're not going anywhere. I think they've been around for at least 15 years, and they've made some of the best analyzer and interfaces that amateur radio has seen. So anybody else have any questions? All right. So, oh, I don't. You know what? It's all online. So I had brochures, and they go out of, all the features change so quickly that by the time you hand out a brochure, the features are now new features and people don't see.
The manual, what is it? Is it a PDF file?
No, manual is actually still a book. Here's an AA, this is an AA-55. And here's the manual. It's written in perfect English, and it even has nice pictures.
Can you get it as a PDF?
You can get it as a PDF as well.
Okay.
So you get a manual.
They're nice. For those of us who can't see as well, it's nice to have a PDF.
Yeah. There's a whole book here, it looks like, on saving and recalling memories and doing screenshots. Software for the computer is downloadable, and that's provided by our company. So if you buy the analyzer, you can ask for that. Here's the difference in the size between the two analyzers. This is the 3555. For a Go box, this is a great analyzer. As you see, it's tiny. For you know, for daily use, though, this is a perfectly fine analyzer. Both are USB. This one is a UHF analyzer, so it has an end connector, whereas this is a 55 megahertz VHF, or rather HF VHF. And it uses the PL259 because we're good.
Are rechargeable batteries?
You can put rechargeable batteries in, and there's a setting for that. The antenna analyzer, it's got a rubber gasket here that tries to keep some water out, and all it uses are 2 batteries, 2 AA's.
Okay.
And that'll last you about, I'd say about 4 hours of measuring continuously.
Wow.
Yeah, you get a lot. This analyzer here, even though it's smaller, uses 4 AAA batteries. Your first set of batteries are included. That leatherette type case that Bob held up, that's included. The SO239 to N adapter is included. That's a $26 Amphenol connector. It's not a cheap Chinese connector because it's important that it has very, very low impedance. Otherwise, it messes with the TDR measurements. And then there's one last thing I'll show you, and that is there's a new analyzer out for you guys who like to do kits. That you might. Hooks up to either, you can plug it into a USB connector directly, or you can plug it into an Arduino. So if you want to build your own antenna analyzer, this little circuit board here is the entire 30 megahertz analyzer, has all the features through software, and it is comes with some pins that you can use to mount it directly onto an Arduino. So get yourself a $35, actually $15, an Uno 2, and snap it right onto that, and you can write all the programs you want. Maybe you have a step IR antenna, and you want it to automatically check your SWR remotely as you move your step IR. It'll keep monitoring it. Of course, you have to write the program for it, but it's a fully functional 30 megahertz analyzer, and the cost on this one is $115, I think. So it's pretty cheap.
Does it pair up with a Pi?
You know, I'm sure you can. You can hook it through the USB because you can get all you need is a USB to wire pin, you know, just a 2-pin USB, and you solder it right onto the board. And you can plug your computer right into that, or plug your RIG or your Pi computer right to it. So the 55, I believe, is $379.95 tonight. I'm selling it if you want one. I don't charge tax, so it'll save you about 9%. And obviously there's no shipping because we're here. The 230 Zoom was $479. I'm selling it for $449. And no tax, again, 9%, and obviously no shipping because I have them with me here. So I've got 35s, 55s, 230s, and a 600. So if you just want to see the 600, I'll pull it out of the box too. But come on up and poke around on it. That's what it's here for. And then if you're interested in one of these to play around with, let me know. I've brought about 4 or 5 of them just in case. So thank you. I really appreciate your attention. I know it's a lot of technical stuff.
Thank you, folks, for coming. There's still some refreshments left. There probably is a little basket there.